Okay, now we see how to identify this hybridization and different compounds. So, well, we know the only central atom. Only central atom of a molecule undergoes hybridization. Okay. Now we calculate the number of hybrid orbitals present on the central atom of a molecule. By knowing the number of hybrid orbitals, we are able to know the hybridization. Now, what is the formula that? The number of hybrid orbitals. The number of hybrid orbitals H is equal to half into number of valency electrons plus number of monovalent atoms minus Cartesian charge units plus anion charge units. Here main important the representation of the symbols. Here V is equal, V indicates the number of valency electrons. Number of valency electrons on that particular atom to which we are going to calculate the number of hybrid orbitals. So M is equal to number of monovalent atoms bonded to that atom. Okay. So here, what is the importance of what is the meaning of number of monovalent atoms? Means which are having a plus one or minus one valency. You know, all halogens minus fluorine minus one, Cl minus one. We know that means the valence means monovalence means which are having plus one and which are having minus one state. You know that fluorine, chlorine, the bromine, iodine, even the hydrogen, or even the presence of NH4 plus. So these are the generally monovalent atoms, nothing but the monovalent we can write the species also present in that particle and present in the molecule which are bonded to that central atom. So what is the C here? C is charge units in cation. The charge unit means no need to write the symbol, just we need to write the how many units of positive charge is present. A is charge units in anion. So how many negative units are present in that anion? So we need to take only that units, not the sign. If so, on this calculation, the number of hybrid orbitals directly we are able to know the hybridization. So, for example, after this calculation for a particular atom in the molecule, if you got the number of hybrid orbitals H is equal to 2, sp hybridization. If the number of hybrid orbitals is 3, that is simply sp2. If the number of hybrid orbitals are 4, sp3. If it is 5, sp3d. If it is 6, that is sp3d2. And if it is 7, it is sp3d3. Okay. Now we see some examples of it. So take the first one. So we are taking general example. Methane. The central atom is carbon. So we need to calculate the number of hybrid orbitals in the carbon. Follow the formula of how many valence electrons present on the carbon? 4. How many monovalent means how many hydrogens? Monovalent comes means generally halogens and hydrogens. Here 4 hydrogens are there which are bonded to this carbon. 4. There is no charge on this. means there is no quaternion charge, there is no anion charge. So finally what half into 8 that is equal 4, this is sp3. Okay, take another example, the H2. The center, we know the central atom is oxygen, so just calculate that one. So oxygen valence electrons are 6, we know that. The number of electrons, the number of monovalent atoms 2. There is no charges present, means there is no anion, no quaternion. So here we get to 4 sp3. And similarly, if you take ammonia, so we must know about the central atom. The valence of the central atom, nitrogen belongs to 15th group. It is having a 5 valence electron. There is 3 monovalent atoms. There is no charge on the total species. So it is also sp3 hybridization. So see some more examples. Example PCl3. So we know the central atom is phosphorus. The number of hybrid orbital H equal half into the valency of phosphorus is 5, whereas 3 Cls. 3 Cls means they are monovalent. There is no charges present on it, so it is 4. That is sp3 hybridization. Means hybridization of phosphorus is sp3 in it. And see some example having the charge. So SO4 minus 2. What is the hybridization of this sulfur? So calculate the number of hybrid orbitals in it. It is half. The central atom is sulfur, having how many valence electrons? 6 valence electrons. So there is no monovalent atoms. Monovalent atoms means generally the halogens and only hydrogen atoms. And there is no monovalent atoms. Plus 0. Next, what is the quaternion charge? There is no positive charges are present. So there is how many negative units are present? 2 units are present. So finally we get that is sp3. We'll have addition of sulfur in SO4 minus 2 is sp3. We see some more examples. There is ammonium ion. So here the central atom is nitrogen. The number of hybrid orbitals equal half into the number of valency electrons in the nitrogen, we know 5. How many number of monovalent atoms? 4. And what is the positive charge unit? That is plus 1. That is minus positive charges 1. There is no anion charge. Here we get exactly 4. That is sp3. Take another one. So BCl3. Here the central atom is boron. What is the boron valency? It belongs to 13th group, nothing but 30 group, having 3 valence electrons. Cl3 means so Cls are the monovalent atoms. 3 are present. There is no charge present on them. It's totally 0. So it is a very good 3. That is means boron undergoes sp2 hybridization in it. Okay, seen SF6. So there is central atom is the sulfur, 6 monovalent 6. So we got 6, that is sp3, 3, 4, 5, 6. Okay. Now what about PCl5? We are taking the regular examples. Half into the phosphorus valency 5, monovalence are 5, there is no charge on them. That's equal to 5, sp3d. Here you take the last one, the IF7. Here the monovalence, the central atom is iodine, having 7 valence electrons and 7 monovalent atoms. There is no charge on them. 7 and 7, we know that if number of hybrid orbitals are 7, that is sp3d3. 3, 3, 6 plus 1 must be there. So that is sp3d3. Okay, now we apply this formula for some more molecules. Okay, see some more examples here. So I3 minus. Here important, very important one, the I3 minus. The iodine is the central atom and the remaining two iodines are the side atoms. So here we can write like this. So the central atom is iodine. The number of hybrid orbitals is 7. So we calculate the hybridization for central atom, means for central iodine. We are having 7 valency electrons and having 2 monovalent atoms. There is no positive charge. The negative charge is 1 unit. We need to add the negative charge. So here we get H equal 5. That is sp3d. Means the iodine hybridization in I3 minus is sp3d. Next see XeF2. So the central atom is xenon. What is the valence electrons in the xenon? 8 electrons. Now 2 monovalent. There is no charge on them. This is 5. It also having sp3d hybridization. Let's see the other compound XeF4. The central atom xenon is having 8, 4. That is 6. sp3d2 and XeF6 is also there, 8 electrons, 6. Then no charge on it, that is 7. It is sp3d3 hybridization. So by knowing the number of hybrid orbitals, we are able to know the hybridization of that atom, a particular atom in a molecule. Okay, this is the method can be used for all type of compounds, positive ions, negative ions, normal molecules, even the carbon compounds. Okay.